Hey guys, this looks like a fun one. Someone decided to put this equation on a hoodie, and I don't know why. It says 4 to the power of the quantity x minus 2 minus the cube root of 2 to the power of the quantity 3x minus 9 minus 60 equals 0. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, I'm noticing we have two terms with an x in the exponent, and both of them can be rewritten with a base of 2. We can rewrite this 4 as 2 squared, and to do this cube root of 2, we can use these notes right here. It says the bth root of x is equal to x to the power of 1 over b. So something like the cube root of 2 would end up being 2 to the 1/3. So we can change this cube root of 2 into 2 to the 1/3. And then next we can use these notes right here. Anytime you have the quantity x to the a to the power of b, you multiply these two exponents. It'll give you x to the ab. So we can do the same thing here. This 2 will distribute to both the x and the negative 2. So it ends up being 2 to the power of 2x minus 4. And same thing here, the 1/3 is multiplied by the 3x to give us x, and then we're going to subtract 1/3 times 9, which is 3. For the next step, we can use these notes here. X to the power of a plus b is equal to x to the a times x to the b. So this 2 to the power of the quantity 2x minus 4 will become 2 to the 2x times 2 to the negative 4. And then we'll subtract this one, and it'll become 2 to the x times 2 to the negative 3. And then we can copy down everything else. Now for the next step, let's use these notes here. X to the negative a is equal to 1 over x to the a. This 2 to the negative 4 will change into 1 over 2 to the 4th, and this 2 to the negative 3 will change into 1 over 2 to the 3. And then on bottom here, 2 to the 4th is equal to 16, and on bottom here, 2 to the 3rd will equal 8. And let's bring these two fractions up front. Now both of these terms contain a 2 to the x. Let's switch the 2 and the x, and let's focus on this 2 to the x. This term has a 2 to the x squared, and this term has a 2 to the x. This is a perfect case for u substitution. Let's let u equal 2 to the power of x. So now we can change each of these 2 to the x's into u's. And we end up with a nice looking quadratic set equal to 0. I don't really like fractions, so let's multiply both sides of this equation by 16. This 16 is going to distribute to all three of these, which will give us u squared minus 2u minus 960. And on the right-hand side, it's still equal to 0. From here, let's try to factor this. To get the u squared, we're going to have u and u. To fill in the rest of it, we need two numbers that will add to negative 2 and multiply to negative 960. That'll end up being negative 32 and positive 30. Negative 32 plus 30 is negative 2, and negative 32 times 30 is negative 960. So if we were to multiply this out, it would bring us back to this step. Since this times this equals 0, we know either this equals 0 or this equals 0. And we can solve these. For this one, we can add 32 to both sides, and for this one, we can subtract 30 from both sides. For this one, we end up with u is equal to 32. And for this one, we end up with u is equal to negative 30. And from earlier, u is equal to 2 to the power of x. So let's substitute 2 to the power of x in for both of these. First, let's look at this one on the right. 2 to the x can never equal a negative number. Here's a graph of it in Desmos. You can see 2 to the x will always be a positive number. No matter what value you choose for x, you will never get a negative number. So this is not possible. But 2 to the x equals 32. This one is possible. Let's see if we can rewrite these with the same base. Let's give them both a base of 2. 2 to what power would give us 32? That's 5. Now since the bases match, we can drop the base. And we end up with x is equal to 5. This is the answer to our question. Let's put a box around it. And I did end up checking the answer. Here's the work. How exciting.